Good morning, party people, and welcome to How to Think Like the SQL Server Engine. When I was working with SQL Server, I don't know about you, but when I first got started with it, I just kind of assumed that it was this really cool black box and that they thought of every possible thing that could go wrong. I mean, after all, the thing is really god-awful expensive. So I thought that they'd thought of every possible scenario of things that could go wrong. And so I just assumed that everything inside there was magic. You know what? It's not magic, and it's actually really easy to understand. Once I start explaining it to you in terms of plain pieces of paper, a whole new world will open up to you in how you treat SQL Server, how you treat your queries, how you treat your indexes, how you treat performance tuning, how you treat hardware. Everything inside this boils down to a few pieces of paper that I actually keep on my desk. The link in this video has a link to a set of PDFs that we're going to use. You don't have to print them out. I know not a lot of us have printers in this day and age, but even just having these PDFs handy will help you understand what's going on inside the SQL Server engine. Let's go get started. So the PDFs, in case you didn't go grab those ahead of time, are over at brentozar.com/go/engine. And the source of these PDFs is actually the Stack Overflow database. Montreux says he has them up on these PDFs up on his second monitor. That's an excellent way to do it. The sources for this are the Stack Overflow database. A long time ago in a galaxy far, far away, StackOverflow.com open sourced the contents of their data. It's all downloadable via Creative Commons. So you can go download it and use exactly the same database that Stack Overflow used when they were first getting started. Now the database structure looks a little bit different today, but the basic ideas are still here in place. You don't have to download it to follow along, and I'm not actually going to do the demos in real time in Management Studio because some of them take a little while to run. But as you're going through the slides for this, if you want to reproduce any of the work that I've done, be aware that everything in the slide deck was done with SQL Server 2019 with the latest compatibility level for that. Defaults for cost threshold for parallelism. We'll talk about why through the course. Any max degree of parallelism is fine as long as it's higher than 1. And I'm using the Stack Overflow 2010 database. Everything that I'm going to teach you in the next hour and a half or so is all going to be relevant for all versions of SQL Server. Everything from SQL Server 7 forward all the way up to SQL Server 2022, Azure SQL DB, Azure SQL DB Hyperscale, Managed Instances, Amazon RDS. Everything that's based on top of SQL Server works exactly the same way. The table that we're going to be working with today is the users table. The users table, if you go into Object Explorer and expand its contents, holds exactly what you think it holds. A list of everyone who's created an account at StackOverflow.com, posted a question, posted a comment. It has columns like About Me, Display Name, Age, Location, Reputation, a bunch of columns. The clustered index of the table, the way that the table is sorted by default, is ID. You see the little key up there next to ID. The primary key, the primary clustered key on this table is ID, which means that the whole table is sorted by IDs. I want you to look at the first piece of paper in the handouts, the white piece of paper. Everything that SQL Server does when it comes to row store indexes, everything is done on 8K pages, and I want you to think of them as literally a piece of paper. Your database is just a stack of 8K pieces of paper. If I think about the data file if I think about the data file, it's just one big long string of these 8K pages. Each 8K page only holds one object's contents. So if I'm looking for a user and I know their ID, I can dive bomb into one particular ID, pull everything up about that user. I can look at their display name, their age, their reputation, all of that stuff. Now, I'm simplifying things a little bit for the purpose of this course. There are some exceptions. For example, look at the About Me column over on the far right. About Me is a big old nvarchar max because it lets people write a long letter over there in their About Me. You know how some people have what Stephen King calls diarrhea of the word processor. Some people like to write a lot, and the stuff that they write could be bigger than one 8K page. It still has to be stored on 8K pages. But in that case, what SQL Server does is instead of putting the whole About Me on the same page, it'll put a little pointer that goes elsewhere, and we can pull that data up off of other 8K pages. That's called off-row data. It covers things like varchar max, nvarchar max, XML, JSON, all that stuff that can be way larger than an 8K page. That is outside of the scope of today's training. We're going to focus on the stuff that's actually on the 8K page. Short nvarchars, dates, numbers, things like that. So furthermore, when we're looking at our database and everything's made up of 8K pages, the clustered index, aka the white pages, is only one possible way that we can store data, but it's the way that we're going to start with. These 8K pages are the smallest unit of data that SQL Server reads from disk and puts up in memory. These pages are identical whether they're in memory or on disk. SQL Server just shuffles them back and forth. These 8K pages are also the minimum amount of data that SQL Server needs to read from memory. I know when I thought I was just getting a row, that SQL Server would magically go on the disk and pull off just one row from the disk, but that's not how it works. SQL Server's minimum unit of I/O for these indexes is one entire 8K page. If I'm going to read a page, I got to go get it off of disk, put it up in memory. Everything that SQL Server does is in memory. If I'm going to make a change to it, if I'm going to insert, update, or delete something on this page, I have to get that page up into memory. I got to make the change, and eventually I'm going to have to write it back down to disk. In a perfect world, SQL Server can easily understand exactly what you're looking for. SQL Server can glance at your query and say, you want user ID 12345. That's easy for me to understand. You're not trying to concatenate strings or variables. In a perfect world, you're only asking for data that's only on one page. Even if you do select star from a table, if that select star is just one row and we're pulling that data off of one 8K page, that's great. It's going to be easy for us to do. Ideally, SQL Server knows exactly which 8K page it is. We're not looking for a needle in a haystack. Through the course of the next hour, we're going to look for a needle in a haystack. In a perfect world, SQL Server has that page cached in memory and can jump directly to that page. And in a perfect world, SQL Server can simply read that 8K data or whatever, how much data you grabbed, out as is without having to change it. You didn't ask SQL Server to run a bunch of complex functions, for example. In that perfect world, our queries are extremely fast because SQL Server knows exactly where it needs to dive bomb down into in order to fetch the data that you need. That's not the world you and I live in, is it? Oh boy, I make a really good living doing performance tuning because that is not the way that people write queries. That is not the way that databases work. Back here in our world, our query is indecipherable. It's a mess of all kinds of joins with functions in the where clauses and functions in the joins. The data that we want is spread out all over the place. SQL Server doesn't even know where it is. We're looking for a whole bunch of needles in a haystack. SQL Server often doesn't have that page cached. SQL Server uses memory for all kinds of things. SQL Server caches data. It needs to do sorts and joins up in memory. SQL Server is trying to cache execution plans too. I see so many people all the time who run SQL Server on something that's got like 32 gigs of RAM or 64 gigs of RAM, and they think it's got big data. You know what? Let me show you something just because it's here. This is my old gaming PC. It's sitting on the floor of my office because I've had it on Facebook Marketplace for a while, and nobody even wants it. It's got 32 gigs of RAM. So every now and then when I'm talking to clients and it's running, say 16 gigs of RAM, I'm like, oh, you want to buy a gaming PC? Which is kind of bananas when you think about how much SQL Server licensing costs. Good hardware has gotten so cheap over the last few years, and people just don't realize that. And then in our world, SQL Server has to do all kinds of work on that data in order to go figure out what it's got to do to render your query results. And in that world, instead of dive bombing into one specific 8K page, we're scanning all kinds of pages. Our job, you and I's job, is to figure out how SQL Server is going to guess the data that we want, how to guess where it is, how it's going to pull that data out of the pages as quickly as possible, how to figure out which tables it needs to process first. And I could go on and on about things like parallelism or memory, but to keep things really simple, I'm going to give you queries, and I want you to build the execution plan in plain English. Forget all the time when I give this class, people are like, I'd build a doubly linked list. I would create a hash tree. I would use a merge join. No. You have a stack of 8K pieces of paper. And you are going to have to figure out how to do that with that stack of 8K pieces of paper. You're not a computer. You got a pencil and some paper. Get to work. I'm going to do the first one for you so that you can see what I mean. First off, select ID from users. That's the query. I want you to build an execution plan. In this case, I'll do it for you in plain English. My execution plan, if I got a stack of these 8K pieces of paper, here's what I'm going to do. I'm going to go grab the first piece of paper off the stack, and I'm just going to start, other way around, reading the rows off of, reading each of the IDs as I go down here. Now, to be perfectly fair, in a real 8K page, the data's not all lined up in columns. It's kind of zigzaggedy over here, because it's not all exactly the length of a piece of paper. But the idea is that we're going to scan from one side of the index to the other, and we're just going to say the IDs out loud. Well, if I take that query and I put it into SQL Server Management Studio, and I execute it with actual execution plans turned on, there's a difference between estimated and actual execution plans. We're not going to cover that in this class. But if I run into Management Studio with actual execution plans turned on, here's what I get. The way that we read execution plans is we read from right to left. There's a very funny blogger, I think it's Rob Farley out of New Zealand, who says SQL Server sucks the data. It sucks the execution plan data over there into the select. It's not entirely true. He's simplifying, but for the purposes of our demonstration, it's true. Execution plans do suck, and so we read them from right to left in the direction that the data is sucked in. And the first thing, in this case, the only thing that SQL Server has to do, is scan the clustered index. That's what a clustered index scan means. So how much work is this? There's a command that you can turn on called set statistics IO on. When you turn set, and it's totally safe to do, you can do it even on the production server. What this does is it returns just a little bit more data over in the messages tab of SSMS. And that data helps give you information about how hard the query sucks. Like Montrose says, they suck in so many ways. The important metric off of here, there are lots of metrics, but the one that's really true and important for us for performance tuning is this one right here, logical reads. What this is it's the number of 8K pieces of paper that SQL Server had to read in order to satisfy our execution plan. Here, 7,405. 7,405 pieces of paper is a little hard for humans to relate to. But remember back when you worked in an office? A lot of you don't work in an office anymore. Frankly, a lot of you never really worked that hard. Regardless, some of you don't work that hard today. But when you worked in an office, you would get a ream of paper when you had to go refill the printer or the copier. A ream, it was about what you could fit in your hand there. Think about having 15 reams of paper, and this is the smallest unit of data in the Stack Overflow database. There's a whole bunch of tables that are bigger than that. But as we're doing this query, I want you to think about an office supply closet over there with 15 reams of paper in it. And when I give you this this query that I want you to build an execution for, you need to start thinking about how hard you're going to work, because you want to, I know you're lazy. You just like to sit around and watch YouTube videos all day. Here I am, thankfully, satisfying that urgent request. So when I give you this request, when I say select ID from users where last access date is greater than 2014 July 1st, I want you to think about how you're going to execute that. Now, here's the catch. You are only the SQL Server engine. Some of you are going to be like, I'm going to build an index. No, you're not. You're the SQL Server engine, which is not allowed to just magically go out and create indexes for you without the DBA actually starting to flip some switches and do some work. By default, no indexes get created other than the ones that you create. So if I ask you to execute this in plain English, type in your answer over in YouTube or in the comments. How do you execute this in plain English? You got 15 reams of paper. Go. See what y'all come up with while I have a sip of my tasty beverage. Refreshing. What you're going to do is you're going to go grab from, as PM says over in chat, the first page or the last page. It doesn't really matter, because if you look at your pieces of paper, they are not organized by last access date. They're kind of scattered all over the place. So we're going to read from one end of the table to the other, and for every row that we look at, we're going to examine its last access date to decide whether or not we're going to say it out loud. Daniel over in chat adds something else. Daniel says, I also want to figure out if I need to go parallel. Do I need to send multiple people into that office supply closet? See, Daniel's not like you. Daniel actually has friends who will go do the work alongside him. Daniel's probably a manager. You know how those managers are. That's exactly what SQL Server does. SQL Server, we're going to read the execution plan from right to left. The first thing that SQL Server does is it does a clustered index scan. But you notice that this one has another operator there, parallelism. The execution plan operator here also has something that Eric Darling, who I think is hilarious, calls racing stripes. He says this operator has racing stripes on it, which means that it went parallel so that it could go faster. SQL Server decided to send multiple buddies all into the office supply closet. And the reason why, there's a couple of reasons why. One of them I find really interesting. I'm going to go back a step to the query. Not all the users match. Before, when I did this, as soon as I grabbed the first pieces of paper, I could simply start yelling out the IDs because I didn't have a where clause. Now I do. Now with my new query here, not all of the rows are going to match. So it might make sense for me to throw more people into the office supply closet to go do this work in parallel, because we're not going to be saturating a network card right from the word go. It's going to take us a while to go through and find some of these users. So by adding a where clause, I might be returning less rows. Does that mean that I did less work? The way that we measure work is a starting point. There's several ways to do it, but as a starting point here, we measure work by the number of 8K pages that we read. The first query is the full complete scan, where we said just give me all the IDs. The second query is the scan, where we only picked specific rows. And you notice something funny. When we only picked specific rows and we sent multiple people into the supply closet, we actually did more work, not less. Here's the thing. Just by adding a where clause and filtering down your result set doesn't mean that you're doing less work. If you don't have a copy of the data that's organized in a way that supports your query, you may actually end up doing more work, especially when there's parallelism involved, since SQL Server sends multiple workers into that office supply closet, and some of them are going to read extra pages. If I compare those two execution plans back to back, the first one is the one with no where clause. The second one is the one without the where clause. Or is the first one's the one without the where clause. The second one has the where clause and it went parallel. Which one of these was harder for SQL Server to execute? Well, you can't tell just by looking at the plans. But the way the SQL Server thinks about the differences between these plans is that SQL Server comes up with something called an estimated subtree cost. You know how your manager says, hey, how long is it going to take you to do X? How long is it going to take you to do X or Y? And you come up with an estimate, and you know how your estimates are always wrong? No, that's not true. Most of the time your estimates are right, but sometimes they're horrifically wrong. This number is SQL Server's estimate of how much CPU and I/O work is involved in executing the query. It's just like a project manager's estimate before the project starts. It's highly unreliable. You do not want to use this to compare between queries, even though it looks like it should. Estimated subtree cost seems like it's going to be useful. It is not. It is garbage, just like your estimates. And so to reinforce that it's garbage, we stopped calling it an estimated subtree cost, and Kendra Little, another blogger in the SQL Server community, came up with this brilliant term. She calls them query bucks. She says query bucks are what estimated subtrees cost, and you can actually download your own query bucks over at brentozar.com/go/querybucks, where we had our artist Eric Larson go through and draw some fake currency front and back with different members of the SQL Server community, which is kind of fun. Generally speaking, when you're looking at execution plans, the higher the estimated subtree cost goes, generally, the longer the query is going to take to run in the project manager's eyes, which of course isn't always accurate. Let's add something else to our query. Let's add an order by. Now, I want you to do this in plain English. I want you to tell me exactly what SQL Server is going to do. Oopsie, I'm trying to hit the wrong key. I'm trying to expand your little chats over there so that I can make sure to see stuff. Sam Smith asks, logical reads means that data that was already in memory, all data that SQL Server works with for queries has to make its way up into memory. So I want you in plain English to tell me how you're going to accomplish this. And all you have are these 8K pages, and it's a lot harder than it looks. How are you going to give me the IDs of the users sorted by their last access dates? Let's see how you're going to pull it off. Give the answer over there in chat. See, one of the reasons that it's harder than it looks, sometimes people will say, I'm going to start reading through these 8K pages, Yeah, I like how David says, I'm just going to add a sort. Right. How are you going to do that as a human being? Wouldn't it be magical if your brain had some kind of sort step? You're a human being. I want this data actually written out. One of the things that people sometimes think is, I'm going to put these pieces of paper in order based on their last access dates. No, you're not. Look closer. There are multiple last access dates on each piece of paper. And you can't hold locks. You have to actually do this work without locking these pieces of paper the whole time that you're working. Locking is a whole other interesting subject. As a human being, here's what you're going to do. As a human being, let me go grab Bob says he's going to ask his kids. I like that. That's usually, and they're going to do the wrong homework, but that's okay because you trained them. What you're going to do is you're going to read through all these 8K pieces of paper first. As you're reading, you're going to be writing something down. What are you going to write down? You have to sort them by their last access date. So you really got to write down two things. You got to write down their ID, and you have to write down their last access date. Alex nails it. Yeah, a couple of you will nail it. Montreux nails it as well. So where am I going to write those? SQL Server actually has scratch pads. And to be technically correct, they're the same 8K pieces of paper that we use for caching query data. SQL Server caches these 8K pages in memory as long as it can. If it runs out of this memory, it's going to spill to TempDB, as Jam says over there in the chat as well. I like to use pieces of notepad paper just because it makes it clear that they're separate kinds of paper, but they're really the same 8K units of data. So I'm going to be writing down last access date and ID, and then I'm going to sort that data as it's coming out by last access date. It's exactly how SQL Server does it. There's no magic to this. We're going to read from right to left, top to bottom. The first thing that SQL Server does is it scans the clustered index. Then you notice after that, there's a separate operator for the sort. Every one of these apps, or I really think of these as apps. This is why I had that little Freudian slip there. I really think of each one of these as apps. They're standalone dedicated apps that SQL Server rearranges on the execution plan in order to go get each piece of work done as efficiently as possible and kind of in standalone units. This one can do its own work without having to know anything about the sort. Then on the next one, this sort can do its work without knowing anything about where the data came from. Let's see and compare how these two execution plans look. The one on the left is before we added the order by. The one on the right is the one with the order by. Now, the estimated subtree cost, remember, it's not really useful for accurate comparisons of queries, but it's interesting to see how much more expensive SQL Server says it's going to be, or the project manager says it's going to be. On the left, we're talking around about 5 query bucks. On the right, once we add that sort, our cost is about 2x higher. And our little execution plan operator has a little thing in it called a memory grant. Memory grant is the amount of 8K pages that we needed in order to sort the data. I told you that we needed a place to write things down and sort it. Before, we had a really tiny memory grant because SQL Server needed a little bit of memory in order to handle the parallelism, sending lots of people into the supply closet. Now, we actually have to go see how much data we're going to sort. Memory grants are an amazing topic in SQL Server. If you right-click on that select and you click on Properties, you get this pane that you always close in SQL Server Management Studio because your boss bought you the really cheap monitor and you don't have enough space on your desktop. But if you leave it open over there, you get this memory grants thing that you see whenever you're looking at the sort. And man, I wish this was sorted differently. Wish that this was sorted in a way that tells a story. But over time, the more that you work with Microsoft products, you learn that whenever they render a screen, they render it in one of two ways. Either they put the data in alphabetical order, which makes no frickin' sense for any kind of logical troubleshooting, Or they load up the data cannon and they fire the data at the screen, and wherever it randomly spreads out and ends up, that's what you get. Like if I look at some of the other tooltips that pop up, this came out of the data cannon. It's all over the place, all over the map. Not in alphabetical order, doesn't make any sense for storytelling or troubleshooting either. So you'll have to forgive me that my hand is going to jump around a little bit here on the page. Desired memory. When SQL Server built this execution plan, it guessed how much data it was going to need. Max query memory. Max query memory by default is 25% of the server's RAM. Any one query can get up to 25% of the server's RAM. I'm going to say that again because it's terrifying. By default, any one query can get 25% of your RAM, and you can't fix that unless you're on Enterprise Edition. It doesn't take a whole lot of 25% before you're screwed. So if you're one of those old school database administrators who thinks that they know everything and they monitor page life expectancy, and when it drops, you go looking for an expensive query that was doing a lot of work, you're an idiot. What you should be looking for is queries that were getting large memory grants. That's your sign that you haven't gone to my training. There you go. So by default, any one query can get 25% of your SQL Server's RAM. Now, because that's so much larger than the amount of memory that we wanted, SQL Server requested all of the memory that it wanted, and it actually got granted all of that memory. These numbers are in kilobytes, so we're talking about 14 megabytes here. When the query ran, the amount of memory that the query ran only used less than that. But that's actually a good thing, because what sucks about this is these memory grants are set in stone before the query starts executing. SQL Server guesses how much memory it's going to need, and man, I tell you what, when I was a developer, I thought if SQL Server wanted more memory, holy smokes, it would just add more memory to the query. If it starts bringing back all kinds of data, why wouldn't SQL Server just grant more memory? But that's not how it works. SQL Server says, whoops, sorry, you can't always get what you want. If you start bringing back a whole lot more data, SQL Server isn't going to grant you more because SQL Server assumes that other people are going to be running queries at the exact same time. So if your query runs out of memory, SQL Server drops what it's doing and it spills data over to TempDB. Here in this case, SQL Server says, I wrote 5,000 pages to TempDB and I read them all back because I ran out of RAM. Which is one of the many interesting things we have to think about when we're doing queries. We have to get these estimates right. Next up, select star. I should push a button here. In plain English, how are you going to accomplish that query? In plain English, does it change the way that you work? A little bit. Now what do we have to write down? As we read through all of the pages, what are we going to go write down on our scratch paper? I'll tell you what I used to think as a developer before I started working deeply with SQL Server. I thought SQL Server would make one pass through and just write down the IDs and last access dates. Then, after it did the sort and it found the data that it wanted, then SQL Server would go back over here and pull all of the columns back. That's not how it works, and that's fair. I understand why Microsoft made this decision. Because if I did it that way, I'd have to lock this data for a really long time, and we're not the only ones using the database. We need to get lots of people in and out of here. So what SQL Server does is it scans through the data, but it makes you write down every single column over on your pieces of scratch paper. And as Montreux points out over in the chat, that also includes those pesky about me's, which are off-row data, which is even larger. Then we're going to sort that matching data by last access date. It's one of the reasons that database administrators get all angry and angsty whenever you do select star. That query sucks. Let's get into a little bit more specifics though. Why does it suck? Do we work harder to read the data? Or another way for me to say that, do we read more 8K pages? You wouldn't think so. You would think that a clustered index scan is a clustered index scan, but it's because of that stupid about me. Now they even want the data that's off row, so we're going to have to work a little bit harder to read the data. If we have a whole lot of about me's that are larger than fits on an 8K page, we are going to have to read more 8K pages. But it's probably not going to be a dramatic amount unless people really love stuffing data in XML columns, JSON columns, and all those. Do we work harder to write the data down onto our scratch pad? And that answer is clearly yes, because we're going to have all kinds of things that we're going to have to write there. Do we work harder to sort that data? The developer in me would have said no, although also I should point out that I was a really terrible developer. And the developer in me would have said no because it's the same number of rows. Unfortunately, that's not true. It's now a giant stack of paper. And we have to shuffle all those 8K rows around as we're sorting. We have to pull all of that data, excuse me, in and out of the CPU's cache. So yes, the sort is harder. And then finally, do we have to work harder to output the data? Yeah, and that was always my thing as a junior DBA. I was like, don't select columns you don't need because it takes longer to yell that data over the network. As it turns out, that's the least of my problems. The big, ginormous problem inside here is that the sort has exploded in terms of cost. It's now up to 97% of that query's cost. And that query's cost has also grown a heck of a lot too. We were around 12, 13 query bucks. Holy cow. Now that we've added select star and the order by, oh, that's giant. As a performance tuner, I am often telling clients, I don't care if you select star. I don't care if you do order by. But so help me God, if you do both of those, we are going to have a come to Jesus meeting. If you're going to do data sorting, go do it on the app tier. SQL Server sorting is insanely expensive for it because we license SQL Server by the CPU core. That's a lot of CPU work in order to do the sorting. If you want to play around with select star and an order by, whammo, sort cost is going to go through the roof, and so is our licensing cost. Our CPU is going to go up to 100%. We'll have to buy more CPUs. And then next thing you know, we're going to have to pay a lot more money on that when in exact same time, we don't pay any application costs for your app servers. Your app servers are, carry the zero, free. So I'd much rather push my sorts down to the application tier when I start to run into performance tuning problems. Now, Haruka asks a really interesting question. So Haruka says, hey, look, oh, I can't put the question up on the screen. It says, can't SQL Server create a virtual table with only last access date and a pointer so that the sort is pretty small? Could they? Yes. Did they? No. And I find that very often when developers learn more about SQL Server, and I'm not saying you're a developer, it happens to everybody, BI people, managers, executives. As people learn about SQL Server, they often have those same kind of questions. Why doesn't SQL Server do it this other way? You know what the common answers are? Number one, nobody knows that they're doing it the slow way. Number two, nobody's complaining that they're doing it a slow way. You didn't know this was happening, and y'all bought SQL Server. I'll leave it at that. It gets worse when it starts to happen more over time. Let me switch over here and put the clicker in there. So it gets worse when it starts to happen multiple times. What happens if I put Go 100 in there? Go 100 tells SQL Server Management Studio, go execute this query a whole bunch of times. Right about now, some of you are writing that down because it's kind of cool. It's not really all that cool, I have to tell you. Unless you're going to try and do a denial of service attack against your SQL Server, you don't really want to run the same query multiple times. Because speaking of things that you and I both wish that SQL Server would do, you and I have common sense. So you and I think that SQL Server would go through, read all of those 8K pages that we have the data that we want. Then SQL Server would go do all this work on the scratch paper to go sort these by last access date. And then SQL Server would say, hey, you know what? Why don't I keep this around for a minute? Why don't I hang on to this for a minute so that in case somebody runs the exact same query again, I don't have to rebuild the wheel? I know I'm not supposed to covet my neighbor's wife, but I sure do covet my neighbor's wife's database. Because this is one of those things that Oracle can do. It's Oracle, every time I look at it, they have all these cool settings. And one of them is they can cache result sets for a period of time. Now, I get all excited about when I go look at Oracle's documentation or I read about the latest and what's new in terms of features, and then I remember that it costs $47,000 per CPU core. I'm not upset about that. I've never had to pay for Oracle licensing in my life, and frankly, I'm glad that other people do because I love to watch sailboat racing, and Larry Ellison spends a lot of his money on racing sailboats and yachts and an island in Hawaii, and you know what? If I could build a database and charge that much and go buy cool things, I would frankly do the same. Microsoft, they're much nicer. They save money on developers and they pass that savings on to you. So when you type Go 100 or you do the same query multiple times, you'll notice that your CPU goes through the roof, and then presto, SQL Server is rebuilding the data every single time the query runs. It doesn't matter if the data hasn't changed. It doesn't matter if somebody else ran the query a second ago. It doesn't matter if someone else is running the same query now. If you run a query multiple times simultaneously or back to back, SQL Server caches this. SQL Server does not cache this. SQL Server doesn't cache query results. SQL Server only caches the raw underlying data. So when people say it's okay, the data's in cache, no, it's not. It's going to suck. All right, so we've been talking for a little while. I've been talking about for 40 minutes or so. So let's talk about what we've learned so far, because things move kind of quickly inside this course. One of the first things that we learned was if you turn on Set Statistics IO on, it shows the number of 8K pages that your query read. This is one of the most important performance tuning lessons when you're trying to figure out whether your queries are performing better or worse. The first metric that you want to look at, it's not the only metric that you want to look at. It's just one of many, but it's the first one that I always go to is Set Statistics IO on. The next metric that you're going to want to look at that we did not talk about inside here is Set Statistics Time On, which measures CPU time. And I feel like I got to mention it, but it goes all over the place based on how much is going on in that query. If you do a where without a supporting index, then you're going to be scanning the table. If you do an order by without a supporting index, SQL Server is going to have a ton of CPU work to do as it scribbles down all this data and goes and sorts it. And then finally, the next thing that you learned inside this first section is that SQL Server caches those raw data pages. SQL Server does not cache query results. Sam says, could you help SQL Server, you meaning really Sam? I don't do any work for Sam, unless Sam is going to bust out those hundos. Sam says, can you help SQL Server results caching by creating a temp table with the subset? In theory, you could. There are lots of things that you could do. You could also put results in Redis. There are all kinds of things that you can do. But part of this class, Sam, is explaining to you that you're the one who needs to do it. I'm not doing it for you. Microsoft isn't doing it for you either. Doesn't that suck? Man, you thought you were going to come in here and you thought you just magically walk out into a much better, smaller, cooler place, or much better, cooler place. I know that when I used to go to conferences and training classes, I thought that when the class was over, I was going to walk out of the class like, yo, I know everything. Bring me all your query tuning problems. I am a god amongst database people. And what I learned very quickly was that the more I learn about SQL Server, the more filled with shame I am. The more I'm like, oh God, I've been doing everything wrong. I hope no one ever goes and looks at my code. I have so much more work to do, and I have so much more learning to do. Which, let's talk about what we're going to learn next. So the next thing that we're going to go learn is we're going to go learn about non-clustered indexes and then the differences between seeks and scans. So let's go jump into that. Sam says, it means I get to keep my job for a bit. Data professionals are going to be employed for a very long time, regardless of what those talking heads tell you about how AI is going to completely automate everything. Good luck with that. I know because I use AI a lot. And it hallucinates like some kind of LSD junkie. So we're going to need to make our result sets go faster. And the first place that comes in is non-clustered indexes. We're going to build a non-clustered index. It's the second page in your PDF handouts. The way that you build this 8K piece of paper is by writing this query. Go create me an index on last access date and ID. The first thing that you're going to notice is that this is literally another copy of the table. Non-clustered indexes just let you choose which columns are on the index, which is really useful if I need to make a specific query go faster. Because, for example, let's say that I need to quickly find people organized by last access date, like we've been doing here so far. I can create an index sorted by last access date, and it is literally another set of 8K pieces of paper with exactly the same number of rows. Now, the good news is that indexes help queries run faster. The bad news is that they also cause queries to run slower, particularly deletes and inserts. Now, every delete and insert that I do has to be echoed across both copies of the table. SQL Server has to get both relevant sets of 8K pages up here into memory, scribble those in, and then it's going to do twice the I/O to write it back down to disk. It's really funny. I run into all kinds of problems as a performance tuning consultant. One of the problems I've run into in the past is that database administrators will say, that storage blows. I know that we have storage problems because my writes are averaging like 100 milliseconds or 200 milliseconds per write. And then I'm like, yo, dog, can you talk to me about this table that's got 320 indexes on it? 320 is a high number. In reality, the highest number that I've ever seen in production is 174, which is a hilarious story that I tell in my Mastering Index Tuning class. The more indexes that you have, you are literally amplifying the number of writes that need to be done on the storage. Updates are a little bit different. They only affect the copies of the table that have the columns that are being updated. For example, if I update someone's last access date, well, I'm going to have to touch that copy of the table. So ideally, I don't index very hot columns that change all the time. We explore that in more detail over in Mastering Index Tuning. Say, for example, that I run the update query. It just so happens that I very recently had a birthday. Say that if you update users and you set my age to age +1, age is not on this index that we created, so I don't have to worry about that extra index slowing me down. But I just need to make sure that you stay aware that you don't index very hot columns if you can avoid it. Yes, That includes the includes, because when columns are included on the index, it is another copy of those columns, and we have to keep those up to date. SQL Server doesn't have the concept of asynchronous indexing. In theory, I want as few indexes as practical in order to support my workload, but I do need to support my workload. If I don't have any indexes, which is what we saw in the first 40 minutes, then every query that I do is a table scan. If I have too many indexes, then every DUI query that I do, it doesn't involve alcohol, that's deletes, updates, and inserts. We both know what you do on Friday nights. You should take an Uber. Instead, when I have too many indexes, that means that my DUI queries take too long to run, and it's a balancing act. So let's come back to the select query that we were doing. I'm not going to do a select star anymore because we kind of understood how bad that is. It's not that you should never do it. I'm just saying that it's more expensive. Select ID from DBO users where last access date is greater than July 7th of 2014 or July 1st of 2014. Go order by their last access date. Now my execution plan gets way simpler. Now that I have that index, I can simply dive bomb directly into the date that I want. To be completely clear, just between you and me, some of the people inside this class are not smart enough to handle this fact, but you are. Also, you smell great, much better than you did yesterday. There are also some other pages that are in here inside this index that help SQL Server rapidly figure out which 8K page on the index has which range of data. So when I do a seek, I can dive bomb into one particular page and start reading there. So if I look at my execution plan and see how that works, my execution plan is now way more compact. It only has one operator in it. I can dive bomb into one particular area of the table and start reading. That's what an index seek is. And you remember before we had the index, it was like 871 query bucks for the select star. It was still kind of high for the selecting just the ID. Now that query cost has plummeted. It's just a couple of query quarters. And who even carries coins around anymore? Dollar bills, y'all. If I compare the costs of those, that cost is now way cheaper even when I have the index. So why is it so much cheaper? I'm going to compare the two queries back to back. In order to do it, I'm going to add a query hint on the first query. That one says with index equals 1. That's useful for when you're doing performance tuning and you say, trust me, I want you to act like there are no non-clustered indexes on the table. Index number 1 is the clustered index. So I'm telling SQL Server, go scan that here. When we scanned the whole entire clustered index, it was about 8,000 logical reads. But now that I'm able to dive bomb in and just get the rows that I want, my logical reads are way down. I'm reading, excuse me, like 20x less data. Now that's kind of intuitive. Most people know that indexes do cause us to do less logical reads. It's also cheaper in terms of CPU. Remember that set statistics time that I hinted at in the last part there? I said set statistics time on shows how much CPU time you burned up. That index, because it eliminated the sort, we don't have to do so much CPU work. So this index that we just created is called a covering index. Covering isn't a term that we use in T-SQL that tells us how to do the index. Covering is just a term that says, for this query right here, this index exactly covers that query, whatever that query is. You can't just create a covering index and have it cover every query that you have. Different covering indexes are required for different kinds of queries. You would be forgiven for thinking that as we were going through this, that an index seek is good then and a scan is bad. And that's not true at all. Because take a closer look at that execution plan. I said, go get me the people who've accessed the system more than July the 1st, later than July the 1st of 2014. Seek makes it sound like I am dive bombing into that area of the table and that I'm only pulling out a very limited number of rows. After all, even the word seek sounds tiny. Seek, seek. It's like something that a hamster or a bird might say. But look at the number of rows that SQL Server pulled out. When you and I hear seek, we think that it means that SQL Server is just going to seek and grab one row and be done. That's not what it means at all. We also think that scan means that SQL Server is going to start at one end of the table and read all of the rows. Take another look at our query. I'm now changing the date to January the 1st of 1800. Pro tip, Stack Overflow, not around in the days of covered wagons. And even though I'm using a date that is way earlier than anything in the table, SQL Server still says seek. Because even though you and I know that Stack Overflow wasn't around in the days of covered wagons, SQL Server can't guarantee that. Even if there are statistics, statistics are just a guess. They're not a guarantee. So SQL Server is going to seek to a particular row and then start reading. The word seek has nothing to do with how much data we read. We can read the whole table, which is exactly what I'm doing here. This is an index seek that read the whole entire table. Well, that index. Similarly, scan just means that I am going to start at one end of the table regardless of what that data is. It just means that I'm going to start at an end. It could either be the start or the end. Don't know which end it's going to be. But SQL Server is going to go to either side of the table and simply start reading. Here's an example of a scan that reads not all kinds of rows. I almost said the wrong thing. A scan that only reads a few rows. See how it says select top 10 stars or top 10 rows from the users table. It says top 10 rows. Well, what would you do if I said go get me the top 10 rows and I didn't put an order by inside the query? How would you execute that in plain English? You would simply grab the first piece of paper off the table. Doesn't even matter whether it's the first or the last. You could start at either end. You're simply going to grab a piece of paper and you're going to start reading until you found enough rows. It's exactly what happened here. There's a top, which is just a cutoff valve. It just plugs off. Here, we're done now with that part of the query. So SQL Server scans until it finds 10 rows, and then it's simply done. So when I compare seeks versus scans, a seek can start at the first row and read the whole table. A scan could start at either end and read just a few pages. I don't want you to think, as I go through this training, that seek is good. David Hicks is using a little bird icon in the chat. That a seek is magically delicious and a scan is terrible. We can't look at execution plans and say, I've got a whole bunch of seeks, my query tuning is done. So now we got non-clustered indexes, and with our non-clustered indexes, we've learned that they are literally a copy of the table. You get to choose which columns is inside there. The good part is that indexes that are well designed can reduce the amount of work that we do for a select. The bad news is that the more that we have, the worse that our DUI operations are. Seek just means that we're going to jump to one part of the table and start reading. Scan just means we're going to start at either end. Seeks aren't necessarily great. Scans aren't necessarily bad. Now, for the second hour of the training, things are going to start to get complicated. We're going to have to talk about how SQL Server makes decisions between one part of the table and another, how SQL Server predicts which one of these it's going to use, how many rows are going to come back from our query, what happens when we need to use multiple indexes as well. Now's a good time to stop for a second and take a quick break and talk about my Black Friday sale. So right now, I'm running a sale. If you enjoy this training, why on earth does anyone continue to watch me? It's kind of amazing to me. I'm just a guy standing in a room asking a database to love him. I don't know why people do it, but if you enjoy my training and if you have a good time learning, and if you want to invest in your career or you want your boss to invest in your career, I'm running a Black Friday sale. It's open now. I leave it open through the entire month of November because I know that a lot of people are having to get their employers to pay for it, and employers don't move very quickly, even when there's a sale involved. So all month long, there are huge discounts on my training classes. You can get save hundreds of dollars across my fundamentals bundle, my mastering bundle, and even my level 2 bundle, which includes all of my training plus software and services like SQL Constant Care and the Consultant Toolkit, which is the exact same utility that I use every single week in order to screen out new clients, tell people quickly what's wrong with their SQL servers, and then do my longer term consulting work as well. All of that is over at brentozar.com/Black Friday. Moss is here in chat as well. Reborn says, without enough RAM, if you don't have enough memory, pages are evicted from the cache pretty quickly. It's absolutely true. SQL Server's trying to gauge which 8K pages it should keep in memory and which ones it should flush out. Because remember, there's also competition for the 8K pages that we're going to use to do query workspace. There's also competitions with always-on availability groups, log management, all kinds of things. People think that 64 gigs of RAM is a lot. It is not these days when you consider everything that SQL Server has to do. And to be frank, SQL Server doesn't necessarily do a great job on managing that memory. Reborn says you need a Black Friday deal for those with the lifetime mastering. There is. So all of my stuff is on sale. If you go to Brent, sometimes I wonder about y'all. There's like a URL up on the screen and it tells you where to go and tells you that things are on sale, and still you ask, hey, wouldn't it be cool if you had a deal? Why don't you go look? Go look, it's right there. I spend my life working really hard trying to make your life easier. Live a little. Click the linkity link. Actually do some work there. All right, now let's come back over and see what we need to go learn next. Also in the paid classes, people don't get roasted as much. All right, so where we left off, we said select ID from DBO users. Go find me all of the users who've accessed the system since July the 1st of 2014, order by their last access date. Let's make the query a little bit harder. Let's go add display name and age. Now how do I execute this? This index doesn't have display name and age on it. This one does. So can I use this index in order to get the results that I want? I can. In plain English, here's one way that I could do it. I could go grab the index and seek to July the 1st. I could scribble down the last access date and ID of all of the rows that match. And then I could go back over to the clustered index armed with their IDs, because now I have their IDs, and I could go pull their display name and age off of this. Sometimes that's how SQL Server works. We read the plans right to left. We also read the execution plans top to bottom. The first thing that SQL Server did was that index seek in order to just grab a few rows off of there. Then it came down here and did this key lookup. Okay, now's the time for me to admit that I lied to you earlier. I can't even go 1 hour of training without lying to you, even in an introductory class, right? But I got to make things really simple when you're just getting on board. We've already figured out that some people won't even click the links that are up there on the screen. I kept this a little bit simple when I said, go create this index. And I said, go create this index on last access date and ID. Technically, I didn't need to do that. Technically, I could have just said create index on last access date. I didn't even have to say the word ID. Because SQL Server will always include the clustering key on your indexes, because we got to be able to join between these two copies. If I go find someone who's accessed the system on a specific date, I got to be able to now go track back over to the table to uniquely identify that row. That's where the clustering key comes in. It doesn't matter if we're only talking about using it for includes. It doesn't matter whether you specifically create the index on there or not. It's not really going to matter that much. It's not like SQL Server is going to store that twice inside the indexes. There are super rare edge cases where it matters, but otherwise, if you need the ID, just throw it inside the index. Now in this query plan here, where we have an index seek followed by a key lookup, where SQL Server had to grab extra data off of the clustered index, that's a pretty classic sign of something that tells us we need to do performance tuning on our indexes. SQL Server is saying that we're going to have to go get additional sets of data in order to satisfy the query. If those columns are really small and you use them all the time, well, you could add them to the non-clustered index. Like if it's, say, display name and age, which don't change all that much. Now you do have to know that the more columns that you add to this, the bigger that it's going to become, the less compression that you get, so to speak. Now, I lied to you again. Oh, man, I kind of pulled a fast one on you here when I ran this query. But when I ran this and I said index seek, sometimes SQL Server goes back and forth, none of you caught this because you're all still hungover from last night. But I changed the date. Did you catch that? That's not the year 2014. It's the year 3014. Because this only really makes sense when I don't have to do a whole bunch of lookups. Let's do what the query really does. If I say go get me all the data since July the 1st of 2014, it's a decent number of rows. And so SQL Server doesn't even use the index at all. It's not even in the execution plan. The only thing that's inside here is the clustered index scan. We're back to the point of we might as well not have an index at all. There's a concept in SQL Server called a tipping point, where SQL looks at these indexes and makes the decisions based on how many rows are going to come back. Does it make sense to use our index, or should just we scan the whole entire table? To learn how SQL Server hints about that, what I'm going to do is I'm going to run two queries back to back. First, I'm going to let SQL Server make its own decisions. And then on the second one, I'm going to put in an index hint. I always think the index hint is such a stupid name. You know how when your partner or spouse gives you a hint? Oh, you know, it's trash can's starting to look a little full over there. They're hinting at you that you need to go do something with the trash can. That's not really a hint. It's really more of a command. It's the same thing inside SQL Server. When I use an index hint, what I'm really doing is forcing it. Hey, yo, you have to use this index in order to execute the query. So now if we compare these back and forth, SQL Server chose to scan the whole entire table and not use the indexes. When I hinted it, same way that my partner hints at me, then now suddenly SQL Server is using the index. Well, did SQL Server make the right decision? To find out why, what we need to do is we need to compare these execution plans. The top one, his estimated subtree cost, which was, remember, measured in query bucks. This is what the project manager thought it would have cost. The clustered index scan is around about 12, 13 query bucks. When I use the index seek plus key lookup, my cost is more than 4 times higher. Because when I start doing key lookups, every additional row that I bring back, that's more reads that SQL Server has to do. A clustered index scan is fixed. It's a known quantity about how many rows we're going to have to read and how many 8K pages that we read. But when we add those key lookups, that's additional work for every single row that we find. This is what really pisses me off about, there's a lot of things that piss me off about execution plans. But when a lot of people see that key lookup, they think, oh, it's a key lookup. It's a singular key lookup. That's not what it is. That's three-dimensional. That really should be stacked off the page. It should explode off the page and punch you right in the mouth based on the, not you, but the person who designed that query. It should go three-dimensional and pop off the page based on the number of times that it was executed, because we have to do that key lookup once for every row that this brings back. We had to do this like 150,000 times. That's one of the reasons that database administrators get so key lookup, oh God, although they're not always really that bad when you're not bringing back 150,000 rows. I would argue, frankly, that whoever would bring back 150,000 rows into their result set is the one that probably needs to get punched in the mouth. I'm not for violence. That's not my thing, and you can kind of tell by my lack of physique there. SQL Server has to make this decision first. SQL Server has to figure out which one of these two it's going to do. There is a hard, firm line in between these two phases. SQL Server isn't like Oracle, where it will recalculate execution plans on the fly. SQL Server is going to have that project manager sketch everything out that needs to be done. And if it's a bad decision, doesn't matter, we're stuck with it. The thing inside SQL Server that does that is a cost-based optimizer, where SQL Server will go build an execution plan, sketch out what's going to be done, guess on the number of rows that are going to come back, and then if it thinks that it's a really expensive plan, it'll go back and build another execution plan, hopefully aiming for a lower cost. The cost-based optimizer is really complex. I think it's a whole lot of fun. I have a disturbing, kinky version of exactly what is fun. Obviously, I'm a bit of a masochist if I'm here working with SQL Server and the binaries. It's not a black and white process either. SQL Server can time out building an execution plan. We spend a lot of time talking about this in the Mastering Query Tuning course. But the big thing that you have to take away, even in a course like this, is that the decision that SQL Server makes in order to decide which query plan it's going to do, one of the big building blocks on it isn't just indexes. But for every index that you create, SQL Server also creates a statistic with the same name. A statistic is one 8K page worth of metadata about the contents of what's in this index. It's just one page. It's one page and that's it. Other databases get to pick the number of pages, they get to pick the number of buckets, all that. Here in SQL Server, we only get one 8K page to describe the contents of this index, regardless of how large your database is. Tens of terabytes, doesn't matter. When SQL Server is trying to design a plan, it gets one 8K page worth of stats for each index, and that's it. SQL Server then uses that minimal amount of data inside of statistics to figure out how many rows are going to come back, which index should it process first, how much space is it going to allocate for memory, how much CPU power is it going to have to use, should it go parallel or not. There's all kinds of really cool things that SQL Server uses statistics for. I'm going to run a command. I don't expect you to run this command ever again, but it's the kind of command that once you know that it exists, it starts to change the way that you feel about query tuning. That command is dbcc show statistics. It's totally safe to run in production, doesn't break anything. All it does is show you the contents of that one 8K page that SQL Server is going to use in order to make decisions. Here, for example, I'm saying, show me the statistics on the users table on that index based on last access date and ID. And it has a few result sets. The first result set tells you about when this index was, or when the statistic was last updated, the number of rows that were in the table, and then you get this histogram. This histogram sounds intimidating, sounds like it's Instagram. It's going to make you feel conscious, self-conscious about your vacations or your weight. This histogram is much easier than that. It's going to make you feel self-conscious about your queries. It is just a list of buckets. For any column, we get up to 201 buckets to describe the data that's inside of it. Why only 201? Well, we're only dealing with an 8K page here. This example here on the screen is that statistics histogram on last access date. Other data types get similar kinds of statistics as well. Here up on the screen, I've got an example of a set of statistics on indexes on reputation. and then another one that's on a string character, like, say, for example, display name. SQL Server uses those statistics in order to understand how many rows are going to come back from your where clause. If we say, go show me all the rows where the last access date is greater than July the 1st of 2014, what does SQL Server do in order to execute that? SQL Server simply pops open its statistics on last access date, because every index has a statistic. Even if you don't create statistics, SQL Server will automatically create them for you. It's very nice like that. What it's going to do, it's going to go down through that histogram. It's going to go find what's in our where clause, in this case, July the 1st of 2014. It's going to go down to July the 1st of 2014 and start adding up all of those buckets. Add it up. Add it up. And then that is where the estimated number of rows comes from. Hey, remember a little while ago when I said that SQL Server either, or Microsoft really in total, either puts data on the screen in alphabetical order or else they load up the data cannon? You can kind of see here, this is the data cannon, where Microsoft loaded it up and went, all right, into battle, wha-boom. And then the data is really scattered all over here in random order. It is absolutely and utterly idiotic that some of the estimates and actuals aren't even next to each other, and then sometimes they are. It's so bizarre how this works. But in this case, SQL Server used statistics to guess that about 148,000 rows were going to come back, and good news, about 148,000 rows actually came back. SQL Server did a good job building estimates, and generally, when your estimates and actual are very close, then SQL Server can use statistics, or that means that SQL Server used statistics. Its statistics were up to date and accurately sampled. Our query was easy to understand, and we weren't doing anything complex like running calculations on there. David Hicks follows up and says, what does SQL Server do to fit the stats on one 8K page when the table has a large number of columns? Each stat is an 8K page. It's totally separate. So how does this go wrong? Well, our stats might be out of date. SQL Server doesn't update stats until a fairly large quantity of data has changed. The stats might have been sampled. The more data that you have, SQL Server can't afford to go check with every row to see what the value is. It's exactly like political pollsters. Sometimes they're vaguely accurate. Sometimes they're laughably inaccurate. You can learn much more about statistics in our totally free class on YouTube. Totally free class over there if you go to brentozar.com/go/stats class. I do have to say that this is more of one of those curiosity classes. It's more of one of those for those of us who love to learn about database internals. It's less about being able to immediately pay off in terms of making your queries go faster. Out in the real world, your queries may not be this easy to understand. Here, this is extremely easy to understand. Here are two ways to write what are the same query. You've had a lot to drink already, and it's early, but you can understand this. Last access date greater than July the 1st of 2014 and less than the next month. You and SQL Server have had a little bit more to drink. So unfortunately, or as I should say, SQL Server and me, I guess, have had more to drink. Here I'm saying go look where the year of last access date is 2014 and the month of last access date is 7. You and I understand that those two things produce exactly the same data. SQL Server doesn't. There are two different execution plans here. One of them doesn't index seek. The other one reads the whole table. Because when you write a very easy to understand query, you make it easy for SQL Server to accurately guess how many rows are going to come back out of that histogram. Because SQL Server can go through the values in that histogram and simply say, oh, I'm going to seek to July the 1st of 2014 and continue reading until I find August the 1st. He'll go through that histogram and add up the number of rows. This query is harder for SQL Server to understand. Here, SQL Server produced a higher estimate. SQL Server estimated that there were 1,700 rows. So because this estimate was higher, SQL Server chose to ignore the index. And I should emphasize, this estimate is wrong. Also, because this estimate is wrong, these two execution plans are different in another way. The top one, because it has the index that's already sorted by date, there's no sort in this execution plan. In this one, because SQL Server used the clustered index instead, SQL Server scanned the whole table and then had to sort the data. To illustrate the cost of that, what we're going to do is we're going to go turn on set statistics time on. Sorting is a CPU-based operation. So then we can compare those two queries. If you do it the right way, if you just explicitly tell SQL Server, here are the exact dates that I'm looking for, SQL Server does less logical reads. SQL Server uses less CPU time. And your query runs faster. Every way that you could possibly slice and dice this, fancy pants syntax loses every time. So it's easy for Mr. Consultant Man from out of town to say, yes, both of these produce the same results, but I need you to write your query as quickly as possible. That aggravates people who write queries. They're like, SQL Server should be smart enough. You take that query down there and I want you to use the index. You shut up and do it. So what I'm doing here is I'm taking that same query, the bad query both times. I'm taking the one that was written to use functions to say, show me the year and month. First one, I'm letting SQL Server pick. On the second one, I'm giving SQL Server that hint, just like my spouse does, saying, hey, wouldn't it be cool if you use that index over there? If I compare those two execution plans, the estimates are still wrong. In this case, SQL Server still estimates on both plans 1,774 indexes. That's because the index hint doesn't affect the number of rows that are going to be estimated to come back from the index. The one with the index does go faster. The one with the index does less logical reads, it does less CPU time, and it takes a little less time to execute. This is what makes beginning performance tuners very angry. They're like, you just need to create, shut up, I'm going to use a hint, just create a plan that uses the index. So why didn't SQL Server choose it? In order to understand why, what we'll do is we'll look at the execution plan costs for both of those. The top one, where SQL Server decided to use the clustered index, the estimated cost of that table scan, what the project manager thought was going to happen before the query ran, was about 6 query bucks. When I look at the index seek plus key lookup, SQL Server knows that that key lookup is a higher cost because it's variable. The number of rows that come back from our index seek might vary. It might be higher. And if it's higher, like SQL Server overestimated how many rows were going to come back, that's why it ended up with that higher estimated query cost. Yeah, it sounds weird that a higher cost query would actually go faster, but remember that the estimate is only from before the query starts. Haruka asks over in chat, how could you possibly guess 0.91 rows, like less than 1 row? Haruka, there's this thing called estimation, and another thing that's going to kind of blow you away, math. So SQL Server can take math, it's really complicated, it's the same thing that your boss doesn't use to estimate your raise because you haven't gotten paid what you're worth. But says, oh, it's going to take you like a day and a half. Right? Because you don't just work in days. The simpler that your syntax is, the faster that your queries will run. And that really pisses off folks who write queries because they're like, but it compiles. It should work. I totally agree. It absolutely should work. And it does work in the sense that the query runs. But unfortunately, it's not fast. Haruka says there's a third thing called rounding. Yes, absolutely. But Unfortunately, they won't round my raise up to the next higher number. Look, instead of paying me 6,000, why don't you just pay me 10,000? 10's a nice higher number. So what have we learned so far? We've learned that a key lookup is when SQL Server wanted more columns than it had in the non-clustered index. Excuse me. SQL Server didn't. Oh, goodness gracious. I'm allergic to key lookups. When SQL Server wanted more columns than it had in the non-clustered index, it has to go do a key lookup in order to get the additional supporting columns. SQL Server has to make the decision about the number of key lookups it's going to do before the query goes in and even starts. That concept is called the tipping point. To figure out things like the tipping point, SQL Server uses a cost-based optimizer. Those costs are just guessed based on the complexity of your query amongst many other things. And the simpler that your syntax is, the more accurate your costs are going to be. So what are you going to learn next? Next up, we're going to talk about included columns and why those sound cool, but they're not magically delicious either. So when we left off, SQL Server was having a tough time deciding between these two different building good query plans for these two different queries. It was able to really easily build a query plan for this. But because our query was harder to understand here, SQL Server made poor decisions. SQL Server had to choose between an index seek and a key lookup versus a table scan. And I mentioned earlier on in the session that a key lookup is a classic sign that you should probably consider, not a slam dunk, but you should probably consider adding a couple of columns to your indexes. If you hover your mouse over that key lookup, you'll see an output list. That's the additional set of columns that you could add to your index, and then SQL Server will be able to run your query faster. Let's go create it. This is the third page in our PDF handouts. This is the gray page on the third PDF page. If I create this index, if I say create an index based on last access date, ID, display name, and age, okay, you're going to notice a couple things. One is that we now have three copies of the table. I should probably work to get that down because this isn't really all this useful. Any query that could have used this index can now use the gray page. Doesn't really make sense to keep duplicate copies of the table around, so I should probably consider chucking this. Another thing that you'll notice is that the stack of pieces of paper for the gray index is going to be much higher than the stack of pieces of paper for the non-clustered index. Because this one has more columns on it, so it can fit less rows per page. The more columns that you put in your index, the larger the index becomes, and to some extent, the less efficient it is in terms of compression. But if you really need those columns, this is the price of doing business. The good news is that even the bad query uses it. Indexes can help overcome problems caused by query complexity and non-sargeable where clauses. Here, even though SQL Server can't estimate accurately the number of rows that are going to come back from it, doesn't matter because this index now covers this query. Bad news is because it's physically larger, it's going to take more 8K pages to store. So to measure indexes and kind of compare between the two and see where the overlap lies, because I told you that you should probably start dropping the narrower copies, in order to figure out, what you do is run sp-blitz index. This is an open source script that's part of our first responder kit. It was originally written by Kendra Little, who's also an interesting blogger to follow. She does cartoons about SQL Server too. It's really fun to learn. If you run sp-blitz index and you say table name users, the first result set that comes out of here lists all of the indexes that already exist on the table. So the first one here is the clustered index of the table. You can tell that because it says over there CXPK. CXPK means the clustered primary key. More about that in the documentation and in my fundamentals and masters classes. The clustered index, because it includes all the columns on the table, the clustered index is larger than the other two indexes. The other two indexes, their size varies based on the number of columns that your index has. The more columns that you add, the larger that your index is going to become, and it's also going to affect all kinds of index operations on there. It's going to affect how long your backups take, how long your restore takes, how long your check DBs take. It's going to affect the size and length of your DUI operations. Every time that you're doing an insert, update, and delete, the more copies of the table, the slower your inserts, updates, and deletes will go. And then if you're doing things like index maintenance, like, for example, Ola Hollengren's maintenance scripts, if you're updating statistics, the more indexes that you have and the more columns that are on them, the longer your index maintenance is going to take. Like Scott says over in chat, there is no free lunch. If you have people who are complaining about slow inserts, updates, and deletes, you probably have too many indexes. If you have monitoring tools that are warning you about blocking and deadlocking, you might have too many indexes. If your large database size is a problem, things have grown up to 10 terabytes and you're starting to ask questions, you might have too many indexes. Because I've seen plenty of cases where people had dozens of indexes on their tables and the total size of the indexes was many times larger than the table itself. On the other hand, you might have enough indexes if people are complaining about slow selects, but they're not complaining about inserts, updates, and deletes. You know what? The vast majority of databases, they fall into this category right here. The vast majority of databases fall into this category right here because people were afraid to create indexes. Then, on the other hand, as soon as they learn about the magic of creating indexes, then a lot of databases fall into this category right here, where people are like, "Oh my God, blocking is happening; it's taking forever," because SQL Server has to grab locks across all these different copies of the table every time we want to do a DUI operation. Sometimes you'll hear people say that there's a fix, which is including columns in an index. And the last one when I created the index, I said create the index on last access date, ID, display name, and age. In theory, you could just include columns, and they're not supposed to be as lightweight. Include means I want you to put them on the 8K page, but I don't want them sorted in order. Who cares? No, really, who cares? What's the difference? Because you know what the size of those two? It's almost identical. One of these has all 4 columns in the key. One of them has 2 columns in the includes. They're about the same size. Oh yeah, but Brent, when they're not sorted, it's totally going to affect how it happens with our inserts, updates, and deletes. It's going to take less time. Included columns are going to be lighter weight. We're not going to have to maintain them as much because they're not sorted in order. Okay, Speedy. Let's test that. Got this row right here. This person's name's Sarcastic. User ID number 643. User ID number 643... he just got older, or she just got older by 1 year. They are now 31 years old instead of 30. If you run an update statement, if you say update users, and for Sarcastic, if their display name is Sarcastic, change their age from 30 to 31. You might argue that, well, Brent, if age is only included, we don't have to sort it. I could just go in there and just scribble 31. Then that way it's much faster. Okay, Speedy. When it's in the keys, that's when we're really going to have a problem. All right, show me. If I change Sarcastic's index or age from 30 to 31, where does Sarcastic move on the page? I mean physically. If you pick him up and move him, where does Sarcastic go? Do we need to move him onto a different page? Or do we need to put him in a different spot on this same page. Look carefully, because the answer is really important. If I only change Sarcastic's age from 30 to 31, do I have to move him on the 8K page, given that this is our index? Just sip of my tasty beverage. Egghat says the jingle is way too loud. Turn down for what? Sorry, I had to do that. I don't have to move him at all, because last access date is really selective. It's not like that affects sort order when that is nearly unique. Think about last access date in a production database. People are changing their last access dates all the time, but they're not unique. People are accessing the site at slightly different times. The leading columns in your index need to be as selective as possible. They need to reduce your search space as quickly as possible, a concept that we go into in great detail in the fundamentals of index tuning classes. The order of the first couple of columns is really important, and you don't generally want to use things like bit columns as your first column. Active, yes, no. Deleted, yes, no. Fan of Brent Ozar, yes, no. You generally don't want to use those non-selective columns as your first columns. Generally, the first couple are very important and they need to be selective. Generally speaking, the columns in your where, your group by, your joins, and your order bys, generally those should go first. And as long as they're generally selective, don't sweat it past the first couple of columns. It doesn't really matter as much whether or not those things are super unique or whether or not they're in the keys versus the includes after the first couple of columns. First couple of columns really important. The rest of them, after all, honestly, really not that important. You can be pretty artistic and flexible with those. There aren't a really lot of hard, fast rules inside of databases. Less indexes that you have and the less columns that they're in them, the faster that your inserts, updates, and deletes will go. But then generally speaking, you're going to want to add more indexes with more columns on them. I would encourage you to do that. I suggest often that people should be comfortable adding up to around 5 indexes per table. Don't be so afraid of creating indexes that you don't want any. You probably want, say, 4 or 5 indexes on every table. Just also know that included columns aren't magically delicious and free. All right, so we've talked about a lot of stuff through the course of today's training class. The place to go next is brentozar.com/go/engine. This has the links to everything that we talked about today, the demos, the slides. It has written versions of this class scattered across blog posts done in order that also go into more details. Then, when you feel like you want to take your career to the next level, your next steps are my Fundamentals of Index Tuning class. There we start talking about how you design indexes for queries, and then after that, the Mastering Index Tuning class, which I would only recommend after you tackle the fundamentals. Of course, what I see all the time, people all the time will tell me, hey, Brent, I think I'm ready for mastering. And then I go, well, did you learn something from How to Think Like the Engine? They'll say, oh, yeah, that was amazing. Great. Do fundamentals. I know the course called Fundamentals sounds like it's going to be really easy. The reality is I wrote my training classes for people who are crushed on time and want to learn the important stuff. I don't do stuff that's like boring and dry as a book. I want you to be entertained and get max value quickly out of there. So I know plenty of people who've been working with SQL Server for 5 or 10 years. They go into my mastering classes going, I know the fundamentals. And then next thing you know, they're like, it turns out I didn't know the fundamentals, Brent. I need to buy those too. Get the fundamentals courses before you get the mastering courses, no matter how cocky you are in terms of the answers. All right, that is everything that I wanted to teach y'all today. I hope you had a great time. I hope you had fun learning. As a reminder, everything in my training right now is on sale over at brentozar.com/Black Friday. So if you enjoyed this class, I always have such a good time teaching these. If you enjoyed this class, head over to brentozar.com/Black Friday, where you can get big annual discounts on my fundamentals classes, my mastering classes, SQL Constant Care, the Consultant Toolkit, and our Level 2 bundle that includes all of those. Reborn Phoenix says, I've been through mastering and fundamentals, and I still learn things rewatching fundamentals every now and then. A really good friend of mine who's a presenter and a Microsoft certified master, she's been working with SQL Server for over 20 years, says, Brent, I know a lot about SQL Server, but every time I watch How to Think Like the Engine, it reminds me of something different inside the engine that I'd totally forgotten about, which I really have a good time with this class. All right, so thanks everybody for hanging out with me, and I will see you on office hours. If you like this too, I have tons of free stuff available on my YouTube channel as well. Adios, y'all. Have a great morning.